Hey everybody. So let's start with more of Chapter 7 about the terrestrial worlds. Now remember that we are going to stop a little bit right after we finish with Mars. So we're going to do Venus and then Mars to talk a little bit about how we do sort of comparative planetology. So we've talked a tiny bit about that. But we are going to go into more depth about planetary surfaces and how they can tell us about the history or about what it's like on a planet if we can't visit that planet. So we'll get there after we're done with Mars. Okay, that's kind of a little extra material that's not really in your book. Anyway, all right. So let's start with an introduction to Venus. Venus is really our twin. It's almost the same size, roughly the same mass, a little less mass, a little lower density, but roughly the same as us, but a very different world than Earth. And there's some really interesting hypotheses as to why it's so different or what caused it to be so different. Because as you'll see in this video, it is extremely hot on Venus, and it has a cloud cover that never leaves, and that is about 8 atmospheres or 8 or 9 atmospheres in pressure. So 8 times the pressure that we feel here at one atmosphere with our atmosphere, and completely unlivable. You would be crushed by that cloud cover, which is really amazing. And it's really comes down to what I think anyway is that it does not have a strong magnetic field, and we're going to see in a video about why that's such a big deal, and why maybe that's the cause or the root cause of why we don't have a wonderful sister world that looks a lot like us and maybe has completely different life but lots of life. It certainly could have worked out that way. Okay, so let's take a look at this video.
Named after the ancient Roman goddess of beauty, Venus is known for its exceptional brightness in the night sky. But behind this facade is a world of storms and infernos unlike anywhere else in the solar system. Venus, the second planet from the Sun, is very similar to Earth from a distance, but up close, it's a very different world. Venus is about the same size as Earth, just slightly smaller. Its structure is also nearly identical, with an iron core, a hot mantle, and a rocky crust. The crust of Venus, however, is dotted with thousands of volcanoes, including Maxwell Montes, a volcano almost as tall as Mount Everest. Venus also has a thick, layered atmosphere. It's full of clouds that rain sulfuric acid and whip around the planet at speeds up to 224 miles per hour, faster than some Category 5 hurricanes. The atmosphere is so thick that it creates a surface pressure similar to what it would be about half a mile deep in the Earth's oceans. This pressure is heavy enough that a human standing on Venus's surface would be crushed. The atmosphere is made of greenhouse gases, primarily carbon dioxide, which create an extreme case of global warming. They trap the sun's heat, causing surface temperatures to rise over 880 degrees Fahrenheit, making Venus the hottest planet in the solar system. Venus is so inhospitable, neither humans nor spacecraft are able to survive the planet's surface. But some scientists speculate that Venus wasn't always so unwelcoming. From roughly 2.9 billion to 715 million years ago, global temperatures on Venus may have been just a few degrees cooler than Earth's are today. And scientists theorize that the surface may have contained shallow oceans that could have held enough water to support life. Today, life may still exist in Venus's atmosphere. About 30 miles up in Venus's clouds, where the temperature and surface pressure are similar to those on the surface of Earth, scientists have observed strange dark streaks that appear to be absorbing ultraviolet radiation, a phenomenon that could be evidence of microbial life. Life may struggle to survive in the atmosphere of Venus, but it is this unforgiving environment that's made Venus an icon of beauty. It reflects 70% of all the sunlight that reaches the planet, which is why Venus shines more brightly than any other planet or star in the night sky. While more than 40 unmanned spacecraft have visited this infernal world, Venus, so illuminated in the darkness of space, still has much to reveal.
Okay, so that's a great little overview of Venus. And so we'll delve in just a little further into Venus. And again, I think this is one of the saddest little stories in the solar system. And that we could have had a sister, and maybe there would have been intelligent life on that sister world, and we could have visited each other. Yeah, it's a sad story. Okay, so as was mentioned in the video, there's, Venus gets about twice the solar energy that Earth receives, but it's not hot for that reason, right? It's hot because of this runaway greenhouse effect, right? So it's got this cloud cover that is just, causing a huge amount of energy to be kept on the planet. So some comes through, like there's a lot reflected, as they mentioned, but if whatever sunlight is coming through is just kept on the planet, which is causing it to be, 800 degrees Fahrenheit on the surface of the planet. You might have noticed in the video that there were some pictures went very quickly past. There have been a couple spacecraft, both of them Russian, that have landed on Venus's surface, but they can only last like an hour or less before they die, right? Basically get crushed or just, stop transmitting. And we have gotten a couple of pictures of Venus's surface, not the most exciting pictures in the world, but, we have actually landed on that planet, we as in Earth, mankind. Okay, well, let's talk a little bit about, here's one of the clues to what happened to Venus, because really the question is, why is it not a verdant, beautiful sister world with all kinds of life? And this is one clue. So if we look at the length of a day on Venus, let's look at this chart. You can see here on Earth, it's one Earth day. This little sun is supposed to be, this little Venus, sorry, or whatever this is supposed to be, tells you the length of the day in Earth days. 1, right, for Earth, right? Mars, day and a half, no problem. Moon, of course, about 28 because it rotates at the same time that it goes around, as we know, right? So it goes around the Earth, takes the same time for it to rotate once. Mercury, as we said, pretty darn slow, right? Like 59 days, something like that. Venus its rotation is 224 Earth days long. Okay, it's one of its days is basically a year, pretty much, right? Close to 365 days. And another weird thing about Venus is that its direction of rotation is retrograde, so it's opposite ours. Now, if you look at the rest of the planets in the solar system, they are all turning on their axes in the same direction as they rotate around the sun. And that is not true for Venus. It's like things got sort of tipped over 180 degrees compared to us. So that's a big clue as to maybe what happened to Venus. Okay, well, there's a couple of things that we think happened to Venus. One was that it probably suffered a collision of some kind. And that is what may have turned it over, slowed it down, and made it so anomalous. And then from there, things began to cascade, which we'll get into. Okay. Venus's surface, as you saw, here's one of the pictures that was taken by one of these Russian spacecraft, I think Venera. Like I said, not the most exciting thing in the whole world, but they couldn't survive very long on the surface. Now, the crust of Venus is much thinner than Earth's crust, which also contributes to why it is not our sister planet. Venus basically has thousands of crustal plates. Unlike the way that we have a few big tectonic plates, our crust is much thicker, and so it's not as brittle, right? It's not as breakable. And so Venus really doesn't have plate tectonics because it has so many of these crustal plates, and they're really thin. And of course, we saw how hot the surface is. So let's look at some more images. Now, remember, these images, these are actually taken by radar, not from anybody landing on the planet, because we could only land on there for a little bit, and the pictures weren't that exciting. But radar can give us a lot of information about elevation of the surface, right? So this is one of those color-coded elevation, and unfortunately, really can't see down here the scale. But blue and purple are, and green are the sort of, looks to me like the lower elevations, and the yellow and red are the higher elevations. That's my guess from this. But this is done by radar and not by anyone landing, and certainly not by visual inspection because you can't see the cloud through the cloud cover on Venus. So you can see here by radar that there's some really amazing pictures of what things look like. Here's kind of a lava flow that's happening, and here's a big mountain that you can see, which is actually a volcano. Okay, so here's one of the big things that caused Venus to go awry, and that is its volcanism. So this thin crust really allowed for a lot of lava flow, right? So because if you have a thin crust, then any little lava comes up to the front, to the top, right below the crust. It can break open that crust much easier if the crust is thin, and cause these big shield volcanoes. And so you have lots and lots of volcanism. Now, every time you have volcanism, you're going to have outgassing of noxious gases. And that's a big cause of what happened on Venus. But I think the bigger thing is, as we're going to see in another video, is the fact that it's got such a slow rotation, caused it not to have a large magnetic field, right? So remember, you've got to have some rotation going for that dynamo inside the core of molten iron to create a good magnetic field. But we'll get into that more when we get to see it in the video. Let's look at the atmosphere of Venus a little bit. Of course, very, very dense, as we said. And it mainly CO2, which, as we know here on Earth, is a powerful greenhouse gas, right? This is what's causing all our problems with global warming. And the clouds here in Venus are made of sulfuric acid and sulfur crystals. So there's sulfuric acid rain. It never actually reaches the ground, but still, you get sulfuric acid rain. It's a nasty place. I told you all those noxious things that are being spewing out by volcanism is causing a big problem. Now, I think one of the big things that broke Venus is shown in this video. Now, this video starts out, it's actually a video about, solar flares and prominences and these really violent things that are happening on the sun that can affect us. So we talked a tiny bit about the aurora that is caused by these charged particles coming from the solar wind and how we have a nice magnetic field that's keeping them away from us. And so this is a little bit about that, but it does talk quite a bit about Venus. So let's get to that video. Here we go.
Coronal mass ejections are huge bubbles of gas threaded through with magnetic field lines. They are part of a larger flow of energy from the sun, including a constant stream of particles called the solar wind. It can travel to the far corners of the solar system, causing even distant Saturn to light up in colorful auroras. To understand what a powerful force this solar flow can be, take a look at Earth's sister planet, Venus. The European spacecraft, Venus Express, recently found that solar winds are steadily stripping off lighter water molecules in its upper atmosphere, sending them flowing away from the planet's night side. Over the eons, what's left in Venus's atmosphere is a witch's brew of acetic gases and carbon dioxide. Looking at Venus from orbit, you'd see a dense layer of high-altitude clouds from 45 to 66 kilometers above the surface. These clouds are so dense and reflective that Venus absorbs much less solar energy than Earth, even though it's 30% closer to the Sun. And yet, down on its surface, Venus is like a house on fire, with its windows forever closed. Venus is in the grips of a runaway greenhouse effect, with an atmosphere that traps increasing amounts of solar energy. Temperatures hover at 464 degrees Celsius, hot enough to melt lead. Air pressures are 90 times higher than at sea level on Earth. At higher elevations, a fine mist forms, not of water, but of the rare metal tellurium and iron pyrites, known on Earth as fool's gold. It can form a metallic frost, like snowflakes in hell. The surface is pocked with volcanic formations, ranging from lava domes to large eruptive summits. With water unable to take hold here, these formations continually replenish the noxious atmosphere. How did Earth avoid such a harsh fate? When a solar blast moves out into space, it extends well above and below the orbits of the planets. Sweeping by Venus, it takes aim at our planet. When it hits, the blast slams into a kind of protective shield, one that Venus lacks. Earth's spin causes molten iron circulating deep in its core to generate magnetic fields. They extend beyond our atmosphere, enveloping the Earth in what's called the magnetosphere. It diverts most of the incoming solar particles past the Earth. While Earth's magnetic field may be strong, it does not shield us from the worst solar eruptions.
Okay, so that's really the end of what we want to see on that video. So let's go back to our slideshow just a little bit and just to point out a couple of things before we move on to our questions. Okay, let's start the slideshow. Okay. So I wanted to point out a couple of things here. All right, so we've had a couple reasons, right? We know that there's volcanism, and that lots of volcanism. There is very thin crust, which can aid volcanism. But this original event that toppled Venus over and slowed down its rotation really screwed with it because it made it so that Venus could not have a good magnetic field to protect itself from the solar wind. And remember, it's closer to the sun too. So as that solar wind comes around Venus, it basically can strip out hydrogen. And then once you're losing hydrogen, you don't have the hydrogen to keep water. So if your water gets sort of split apart into oxygen and the hydrogen gets pulled off the atmosphere, it just never comes back. And water can be a protective thing for when you have, volcanism. So, for instance, you could have volcanoes that are covered with oceans, which we have had, that basically end up building up islands like the Hawaiian Islands, etc. So this sort of tipping over and slowing down that happened to Venus was one of the big contributors to the fact that it is not a beautiful, verdant sister planet for us, which is a pretty sad thing, I must say. It is an interesting world, of course, because of all the extreme things that are going on, right? Sulfuric rain and all kinds of things like that. And I think I misspoke when I said it was 8 or 9 atmospheres. It's 80 or 90 atmospheres. And pressure underneath that on Venus's surface. So it is very interesting, but it is kind of sad. Anyway, that's it for Venus. And let's time for a question. Pause your video.